This is a video presentation of Chapter 7, Section 3 in the 8th grade Holt textbook entitled Triangles. Our objective here today is to find unknown angles and identify possible side lengths in triangles. So what we start off with there is the definition of the triangle sum theorem. And the triangle sum theorem is really one of the most basic fundamental properties of a triangle. But it's very, very important because beyond a triangle, when we study the other sided shapes that are two-dimensional, squares, any quadrilateral really, pentagons, octagons, when we make those shapes, when we study them, when we go into actually more details about them, what we usually do when we do that is we chop them into triangles, which is a process called triangulation. So the more we know about triangles, the more we know about the other shapes, really. So that's why the triangle sum theorem is important, because it's one of the basic properties of a triangle. And that's the theorem that states that the angle measures of a triangle add to 180 degrees. No matter what way I draw the triangle, those three angles in that triangle are always going to make 180 degrees. Now the next thing they talk about there, the next three definitions there, are definitions that describe triangles by their angles. They're simply descriptors. An acute triangle is a triangle that has three acute angles. And you know what an acute angle is. If you've forgotten, take your finger and your thumb, make that L shape we've talked about before. And then what I want you to do is start pulling your finger and your thumb closer to each other. And as you do that, what you got are acute angles. So three angles that are less than 90 degrees. A right triangle is a triangle that has one right angle. The right triangle is a triangle that has one right angle. Now it can't have more than that. Think about it. What is a right angle? 90 degrees. How many angles does a triangle have? 3 angles. So let's just say I could even have 2 right angles there. So that would mean really that I have a 90 degree angle plus a 90 degree angle. Well, that would make 180 right there. So I'm already at my limit for the angles, but I still have a whole other angle that has nothing to it. You can't do that. Right? That's why a right triangle only has one right angle, because any more than that, and you're going to be oversized and an angle short. An obtuse triangle is a triangle that has one obtuse angle. And again, the reason it can have one obtuse angle is the same logic as the right triangle can only have one right angle. What is an obtuse angle? Remember, that's bigger than 90 degrees. Take your finger and your thumb and make that L shape and then stretch them out a little bit further. That's the obtuse angle. Well, let's say I even pick the smallest ones I can pick, 91 degrees. If I put 2 of them together, that's 182. I've gone over the max, and I still haven't even hit the third angle yet. All right, so you can never have more than one right angle or more than one obtuse angle when you're making right triangles and obtuse triangles. Now, what we talk about in the next 3 definitions are triangles by their sides. We've got an equilateral triangle. An equilateral triangle is a triangle with 3 congruent sides and 3 congruent angles. If we know one of those pieces of information, the other one automatically has to be true. So if we see that a triangle has 3 congruent sides, meaning 3 sides that have exactly the same measure, we know automatically that the 3 angles in that triangle are all the same. Same thing going the other way. If I see a triangle where all 3 angles are 60 degrees, which is all they could be to fit that mold there, then the opposite direction flow is true, that all the sides have to be exactly the same. What they're the same as, that's what we have to figure out potentially, but let's say one of them then is 6 inches, and I'm saying to you, well, all 3 angles are the same in this triangle, and that means the other 2 sides would also have to be 6 inches as well. An isosceles triangle is a triangle with at least 2 congruent sides and 2 congruent angles. Again, same logic here. If I show you that 2 angles are exactly the same, two sides then also have to be exactly the same. That means if I show you two angles the same, it's isosceles. If I show you two sides the same, it's isosceles. And again, if I show you two sides the same, the opposite direction of information flows, that means two angles are going to have the exact same measure. A scalene triangle is a triangle with no congruent sides and no congruent angles. So a scalene triangle, nothing is going to match up. No sides the same, no angles the same. Again, a scalene triangle is a triangle with no congruent sides and no congruent angles. And then the triangle inequality theorem is, again, one of those basic principles of a triangle, although we use it a little bit less probably than the fact that the angles add up to 180. We say here that the theorem that states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Again, the triangle inequality theorem states that that's the theorem that states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So what they're saying there is match any two sides of the triangle you want. Pick any two you want and put them together. When I add those two together, it has to be bigger than the number I left out. If it's not, you don't really have a triangle.